Welcome to Computex and to this era of pervasive data-driven experiences. I'm David Moore, Senior Vice President and Chief Strategy Officer at Micron, and I'm pleased to be able to join you today to share our vision of how we see a world and future increasingly being shaped by data. I will be joined today by Sanjay Mehrotra, President and CEO of Micron Technology, as well as guest leaders from across the industry to provide thoughts on some of the technologies and experiences that will reshape our lives in virtually every way. We are at a unique and exciting time where technology has placed the physical and virtual worlds at a convergence tipping point as they become further intertwined across almost every aspect of our daily lives. As our interaction with the world alternates between the physical and the virtual, there is a common link. And that link is data. Even today, nearly everything we do, anywhere, manifests itself in data. Across almost every industry and aspect of our lives, we see the transformational effects of data really underpinned by three primary forces. First, the digitalization of the global economy. Data increasingly becoming a critical part of how we live and how we work. Second, hyperconnectivity, the right connections anywhere. Every human and every machine potentially communicating and sharing data for the benefit of all. And incredible advances in artificial intelligence, capturing and creating new value through insights from that data. These forces are key drivers for accelerated growth in the amount of data generated. Current forecasts show that the amount of data created globally will more than double by 2025 to reach a staggering 180 zettabytes. Now, I know it's not always easy to picture what 180 zettabytes is, so just to help contextualize that, just 1 zettabyte represents more than 300,000 years worth of 8K video data. The impact of this data growth will be considerable in many ways, but this expanding universe of data will both connect us and empower us. This data and the knowledge and insights we derive from it open the door to amazing and exciting opportunities for innovation, invention, and advancement. As individuals, we will gain new experiences and open up new ways we engage in the world, further extending the advances we've made in online social communities by exploring them immersively and in 3D. Business will find unrivaled opportunities for improved efficiency and scale. Technology continues to deliver new ways to improve productivity by easing human-to-machine interaction and increasing automation. Virtual economies based on blockchain and smart contract technologies will expand those opportunities and open the doors to entirely new business models. We live in exciting times. By embracing the growth in data as an opportunity and coupling that with the rise of hyperconnectivity and the advancements in insights through AI, we are seeing a new era of use cases and experiences never imagined before. When you think about many of these new user experiences, the first place you have to look is mobility. Allowing data to move with the user or to be seamlessly accessible while on the move will continue to be central to a more pervasive, a more connected experience. The rapidly ramping deployments of 5G throughout the world is further altering how and where we work and play. While only 15% of the world had 5G availability in 2020, we expect to see that hit 75% by 2027. 5G takes user experience to the next level. 5G's greater network capacity, lower latency, and ability to slice network bandwidth for different quality of service needs, and of course, up to 10x faster speed, make new and innovative use cases possible. As 5G is still in relatively modest deployment worldwide, and we're only seeing the initial implementations of emerging use models today. Today, 5G connectivity is driving an enhanced mobile experience through incredibly capable smartphones, tablets, and IoT devices. An experience that is truly remarkable. 5G uptake is surging, expected to reach 1 billion subscribers over 2 years sooner than 4G did. However, 5G is more than just about a better mobile experience. 5G promises enhanced broadband, ultra-reliable, low-latency communication, better security and power efficiency, and massive machine-type communications. These capabilities are open up use cases in areas such as industrial, precision medicine, and autonomous vehicles, to name but a few. In fact, 5G will have a tremendous impact to our economy. Fast, intelligent internet connectivity enabled by 5G technology is expected to create approximately $3.6 trillion in economic output and 22.3 million jobs by 2035 in the global 5G value chain alone. Today, people think nothing about recording high-resolution, live short-form video, editing it, and sharing it with friends in real time. Now, not that you'll see me much on TikTok, but I can vouch for my kids in this aspect. That adds up. 20 petabytes of data is generated on TikTok from the creation of only just one short-form video by 83% of monthly average users, even at value phone-friendly 720p resolutions. There are increasing demands for enhanced productivity and multitasking. Next-generation foldable smartphones enable seamless workflows, allowing content creation, editing, storing, and sharing from one device. It is hard to beat the combination of a usable screen and powerful connected systems. Mobile gaming is an example where people will spend hours engaged on a tiny screen. And I don't think we need any more proof of popularity than the sheer number of global game consumers and how much they love their games. A number of games have been downloaded over 1 billion times, and many more have hundreds of millions of downloads. And why not? The mobile gaming experience is excellent. Smartphones are enabled with console-like hardware and software features, ray tracing, and HDR. What was once a constrained and limited experience has transformed to be highly engaging, if not addicting. I cited the wide availability and advancements of 5G as a key enabler of this change. And I spoke briefly to other key capabilities such as high-resolution cameras and software. But make no mistake, there are enormous advancements in the underlying device hardware that allows these experiences to manifest. The growing capabilities and advancements in mobile memory and storage is no small part of this. I'd like to share a data point here to really just illustrate how mobile memory and storage have evolved. Memory and storage technologies and average device capacities for each have evolved hand in glove with phones as they take on more, faster bandwidth and other capabilities such as sensor integration and improved camera functionality and software. Current flagship phones are incredibly powerful systems with ample compute, memory, and storage capabilities to be able to handle increasingly complex demands and data-heavy tasks. Micron has been instrumental in enabling this evolution. We've invested and partnered deeply, emerging as the leader in developing critical innovations in packaging, power reduction, and process technologies that allow for the integration in a wide array of devices of different sizes, capabilities, and price points. We've worked with partners, creating the devices that address the workloads and use models that span the massive capacity needed for the most demanding use models. These include computational photography and video, natural language translation, personal voice assistants, and mixed reality, AR, VR, and more. Getting there requires an enormous amount of innovation and collaboration with phone developers, and especially our partners developing the increasingly sophisticated and optimized system on a chip, or SoCs, that power these advanced phones. Mobile ecosystem collaboration is critical to delivering end-user devices that truly push the boundaries of what's possible. Market leaders who lead with a vision built on innovation, next-generation technology, and delivering exceptional user experiences are pivotal to the mobile ecosystem acceleration. I would like to introduce our ecosystem partner, MediaTek, and JC Su, Vice President and the General Manager of the Wireless Communications Business Unit, to share his perspective on what's next in mobile.
For several quarters, MediaTek has been the number one in the smartphone chipset market by sales. And we are driving next-generation 5G smartphone experiences through milestones of innovative technologies in our entire portfolio of SoC designs. From entry to flagship, the MediaTek Dimensity series gives 5G that constantly on the cutting edge, professional-grade imaging and the multi-camera videography, brilliant non-stop gaming, and advanced AI that helps everywhere. All these are smartphone experiences that matter most to end consumers and they are also all data-intensive actions. Collaborating closely with the best component makers in the mobile ecosystem is important for MediaTek to provide consumers with the best smartphone experience. Our close co-working relationship with Micron has given us a competitive edge on memory and storage in the smartphone ecosystem. In November, together we jointly validated the world's fastest LPDDR5X used in flagship smartphones powered by MediaTek Dimensity 9000. This ensured the fastest possible data streams between our flagship chip and the main memory, giving smartphone designers truly next-generation functionality and performance to build on. We look forward to continuing to work with Micron to bring SoC, memory, and storage innovation together, leading the market to enable exceptional smartphone user experiences for everyone. The way consumers use their smartphones is what we focus on when developing our smartphone chips. Macro trends such as user-generated content and short-form video, gaming and photography, in all conditions demand extremely responsive SoCs equipped with speed that never feels slow, and all without sacrificing battery life. Our Dimensity 5G chips are created to provide the best user experience in everything from mainstream to flagship smartphones.
Thank you, JC. You know, JC makes some very astute points, and one can never go wrong when you have customers in mind and are concentrating on understanding what they really need. This mindset always leads to great innovation. You know, in that same line of thought, changing user needs and making new experiences possible has led to something of a renaissance for one of the traditional ways we've accessed data, the client, in all its diverse physical forms. The personal computing experience has come a long way. Virtually every aspect of it has become faster and richer and more intuitive as the hardware and software have evolved, and the cloud has expanded as a vehicle to enable leisure, shopping, collaboration, and business in deeper and more engaging ways. One potential destination state of the experience evolution is what many are now describing as the Metaverse. And while we can debate what to call it and whether there is one metaverse or there's many metaverses, I don't believe we should doubt that there will be a tremendous advancement and transformation in how we engage our world digitally. We like to think of these environments as the digital dimensions of human experiences, evolving through new data-enabled experiences and transformative new business models. When you think of what this includes, it makes perfect sense that people will be lured back on their PCs to engage in virtual environments. Environments that provide networked digital worlds that support continuity of identity and objects, including history and payments and asset ownership. Connected to an online framework that permits live social connections, content changes, and monetization. Experienced synchronously and interactively by a set of users, each with an individual sense of presence. Engaging virtual and collaborative environments have changed the behaviors of so many. The number of people engaging in social media and collaborative environments is incredible, as is the amount of time that they spend in these environments. 4.6 billion people around the world now use social media. Over 400 million new users have come online within the last 12 months. The average daily time spent using social media is nearly 2.5 hours. We see a similar phenomenon in the world of gaming, a world of realistic environments and interactivity. Market research forecasts that just under 3 billion people, more than a third of the global population, will be gamers by the end of this year. They will spend an amazing estimated $189 billion on gaming. As a point of comparison, just for context, the global box office receipts for all movies in 2018, the last pre-pandemic year, was under $42 billion. Gaming is an incredibly large market, and these are people we know and work with every day, and many of you too out there, I am sure as well. Many metaverse environments borrow heavily from technologies and techniques used in the incredibly realistic fast-paced gaming environments. The systems they will need for these immersive, real-time, interactive experiences will likely be high performance and richly configured. As an example, to interact in a metaverse world, among other things, you'll need a higher-end processor and a great network connection. But having a high-performance graphics card equipped with ultra-bandwidth memory called GDDR6X will ensure you get the most realistic visual experiences. But it also takes a balance system to make the environment engaging. And that means high-performance memory and storage that keep up with these CPUs and GPUs and can handle the vast amounts of data needed to transmit, store, and manipulate environments in real time. While our primary objective here at Computex is to share our vision, these are areas where Micron is innovating to make these experiences a reality. Today, DDR4 is the pervasive DRAM technology, but bandwidth limitations coupled with more enhanced computing needs mean you're restricting user experience. However, DDR5 breaks through DDR4's bandwidth limitations for next-gen multi-core CPUs. With Micron and crucial DDR5 memory, customers can harness its massive bandwidth right out of the box. Larger 32 gigabyte DIMMs mean higher system memory capacities, and they're available to handle large engineering or content creation tasks. Onboard ECC and enhanced CRC provide more integrated data integrity capabilities. Tighter signaling and monitoring elements provide increased robustness against outside interference. In all, DDR5 is a great choice for the latest generation computing platforms. NVM Express, NVMe, has been a transformative technology in recent times, providing a standard interface that enables design flexibility while opening the door for the incredible performance inherent in advanced NAND technologies. Without it, high performance would have been stranded, isolated behind legacy storage interfaces. We're announcing some updates to our broad portfolio of SSDs that will be of great interest for those looking for storage capacity and performance upgrades. These are NVMe 3D NAND drives that extend our leadership in QLC NAND SSDs. My friend and colleague Dinesh Bahal will provide a much deeper view into the uses and product capabilities of both key technologies in his Friday forum session. And I certainly encourage you to join to learn more on how we are delivering across performance and value requirements. Now, our engineers are busy in the labs today, working with our partners such as AMD and Phison to put final touches and testing and verification of the platforms that will enable the next step for client storage, PCIe Gen 5. We are excited to support performance and capabilities enabled by the next generation client systems, featuring the latest multi-core CPUs, complemented by high-speed, high-bandwidth DDR5 and new high-performance PCI Express Gen 5 based SSDs. We've spoken about how 5G is opening up new use cases, and that mobile and devices are the benefactors of that. But what is the enabler? Well, the edge, or intelligent edge. You may hear many explanations of what the intelligent edge is. Quite simply, it's the placing of resources at the location of best return. Whether that is an immersive experience in the metaverse that requires low latency, or a factory relying on machine-to-machine communications and AI for factory automation. It's the intelligent edge that really enables this. The edge for me represents the gap in the connectivity and processing resources, including memory and storage, required to deliver captivating experiences in real time to hyper-connected devices and users. Now, not all requirements for latency and responsiveness, realism, interactivity, and more can be really delivered on a device or through a hyperscale cloud half a continent away. That's regardless of how much bandwidth we have to our local access point. Physics ultimately wins. And it takes time for data to go from the user through a network to a system that can process it, and then come back again. And for a growing number of use cases, that model just doesn't work. The user experience breaks down. The world requires an intelligent edge as a complement to basic connectivity to provide seamless experiences for all. What determines workload placement? Well, I mentioned geographically induced latency a moment ago, but there are other factors, including data transport costs, security and sovereignty, availability and local support for services, and data value ephemerality. We are already seeing a tremendous investment in building infrastructure for the edge. Hyperscale cloud vendors building more regional data centers in order to get closer to the customer and address other concerns such as governance, for example. There's been a growing shift in distribution of where data resides and is processed. We've shared how devices were getting smarter and capable of capturing or generating more data thanks to new functionality. This is shown pretty clearly in the robust CAGR for data growth in endpoint devices, roughly double the growth rate of the traditional core cloud. Edge computing allows more opportunities for analysis of data and closing the loop on automation, and taking actions based on data to be much more responsive to business needs. For example, sensor data from a local machine may indicate that it'll be shut down due to overheating or performance degradation over time. The same sensor data from its machine can be used at a building or campus level and in aggregate be correlated to determine risks of larger scale system failures and even optimal maintenance scheduling. Regionally, the system and productivity data from these machines may be helpful in shifting overall productivity or influencing energy procurement policy. Now, my next guest can provide some additional compelling insights into how data aggregation analysis at various edge locations can provide significantly more impactful experiences and business results. I'm really happy to introduce Bruno Fernandez-Ruiz, co-founder and CTO of Nexar Inc.
We founded Nexar so that your child will be safe when crossing the street. Today, cars can't see around the corner or behind the truck, as visibility is blocked. When cars share what they can sense and they can see with each other and in real time, we can keep cars and vulnerable road users safe on the road. Nexar collects, analyzes, aggregates, and broadcasts billions of data points per hour at the edge. This vision-based AI platform is based on a network of vehicles currently driving 200 million miles per month, creating a new layer of information that provides an unprecedented real-time view of the road ahead. This video really captures the essence of what you discuss in terms of building out an intelligent edge, paving the path for smarter mobility, safer roads, and autonomous vehicles.
Keeping the roads safe and clear can be a daunting task. A blocked lane due to unscheduled construction, a pothole on the road, a missing street sign. These can lead to congestion, vehicle damage, and even life-threatening conditions. Crowdsourced vision data can help us see around the corner. Nexar collects crowdsourced vision data from vehicle cameras in a scalable and economical manner in order to provide real-time dynamic road services to drivers. They share data from the world in real time, mapping transient and static road elements to ensure a safe and more efficient future of driving. By using Smart Vision AI on device and on edge at the mobile network operator premises, Nexar overcomes the compute and connectivity challenge. This is the only way to achieve the low latency required for applications that provide near real-time information about the road.
My thanks to Bruno for sharing his great examples of how the edge is really impacting the world as we know it. Edge is evolving as an extension and a complement to the traditional data center. The enterprise or public cloud data center is a critical component of any vision of a pervasive, data-driven experience story. Many interactions in the physical world and in the virtual worlds will require a data center backend. Data centers house roughly a third of all data on Earth today, roughly 20 zettabytes in 2020, and are projected to grow between 15 and 20% annually through 2025. The challenge is not only the sheer volume of data and users that must be supported, but also the need for time-sensitive processing and responsiveness. The evolving nature of workloads and services that they provide also poses new considerations for data center managers and architects. How can data centers deal with this volume and growth and changing workloads efficiently? Well, general purpose computing and open platforms are a prime source of efficiency for dealing with data and services at scale. And this is largely due to two factors. Firstly, large-scale operators evolve models for building and operating data centers at unprecedented scale-out architectures. The second factor is enabling scale-up, optimization via the addition of heterogeneous compute elements. As cloud, virtualization, and hyperscale approaches have matured, workloads and services also have evolved, becoming more microservice-oriented and more composable. These include voice processing, video analytics, data mining, intensive simulations, and realistic visualizations, to name just a few. This means that a growing number of services will likely require far more than your run-of-the-mill general-purpose server to operate effectively and efficiently. Fortunately, general-purpose platforms have the flexibility to adapt to needs. Consider our examples here. The system on the left is configured to provide the resources that roughly match a general-purpose server instance at a cloud provider to meet more traditional workload requirements. The system on the right represents a resource configuration for an instance intended to process an AI-centric workload. This configuration has many times the compute, memory, and storage capabilities, 8 GPUs, each with gigabytes of dedicated high-bandwidth memory, multiple CPUs, much more storage and memory relative to a general-purpose system. Clearly, one size does not fit all. Automation of provisioning and workload placement can help, but only if the required resources are available to be used. So the ability to transform the general-purpose server into a composable platform, providing the acceleration and storage and memory necessary to meet workload requirements, is critically important. Being able to utilize open platforms works, as long as all of the ingredients can keep up with the requirements. If not, the system can become unbalanced. We may see bottlenecks between the CPU, memory, accelerators, storage, or I/O. The result of that is often bad response times, maybe dropped packets, pixelated videos, leading to bad user experiences and the potential for lost business. A primary focus for Micron is to stay ahead of that curve and to work with our key ecosystem partners and standards groups, such as OCP, to advance memory and storage technologies as part of scalable platforms. This includes innovations in DRAM and NAND architectures to meet emerging needs and to combine with new CPU, graphics, and I/O devices and enable breakthrough performance and efficiency. We are the industry leader across DRAM and NAND, thanks to our 1-alpha and 176-layer NAND technology processes. Process advancements are always exciting and promise major leaps in performance, density, and capacity. But we also continue to deliver advancements within our current process generations too. For example, earlier this year, we announced our new addition to our data center SSD portfolio. This new drive, the 7450, is based on our proven leadership of 176-layer NAND. And through the use of Micron DRAM, a Micron-built controller, and our unique secure execution environment, we are able to create an enhanced solution that delivers 2 milliseconds of latency at 6 nines quality of service, and with more robust security. Our collaboration and innovation does not stop with Micron or our partners. We contribute significant quantity and quality of experts to the key standards that have been making open systems innovation so successful for so long. Bodies such as JEDEC, MVM Express, and SNIA communities benefit from Micron's contributions and leadership in key technical committees. With that in mind, I'd like to highlight some major standards-based technologies that promise to make a major impact in data center environments. These are Compute Express Link, or CXL, and DDR5, which I touched on earlier in our client discussion, but would like to revisit in the context of data centers. So CXL is a new server interface that enables unprecedented levels of system composability and efficiency. This is a real breakthrough and allows completely new ways to implement additional capabilities onto a general-purpose platform. CXL builds off the base of PCI Express and resolves many of the issues and limitations with previous bus expansion architectures, and it allows for incredible flexibility. With CXL architectures, capabilities such as memory, accelerators, I/O devices, and storage can be easily plugged into the system, accessible via high-speed connections to all CPUs. This is particularly promising for acceleration and memory expansion, which can struggle to scale effectively given traditional limitations on available DIMM and PCI slot resources. For example, CXL 2.0 promises a 32 gigatransfer per second full duplex infrastructure to accommodate additional low-latency resources. If a system needs many workload accelerators, such as our AI workload configuration example that we showed earlier, that's easily added. If more memory than the available DIMM slots allow is required, additional memory can also be attached via CXL. This allows the creation of enormous pools of memory to be shared by any of the high-performance processor cores and accelerators, and enables breakthrough levels of flexibility and scalability. The imminent impact of DDR5 in the data center will be even more profound. DDR5 was designed for the demands of the data center. In terms of memory innovations for the data center, it is a game changer. Data centers transitioning to next-generation server platforms starting later this year will be challenged by platforms with hundreds or more processor cores each, and incredible low-latency I/O needs. Memory is a crucial part of allowing these high-performance compute elements to be able to handle data efficiently, and DDR5 will deliver the goods. Micron DDR5 delivers more than double the bandwidth, offering the next generation of performance, reliability, and scalability with lower total cost of ownership advantages over DDR4. We've been working with partners across the ecosystem over the last 2 years to be ready for DDR5 through our Technology Enabling Program, or TEP, which has provided early access to documentation and design tools needed to build DDR5-based systems. More than 450 systems designers have used TEP as the pipeline for new capacity points and speed bins get defined. This collective work has readied the industry for DDR5 adoption. To get another view of the enormous opportunity for advancing data center capability, I'm very pleased to introduce Robert Hormuth, Corporate Vice President, Architecture and Strategy at AMD.
Modern workloads are redefining the next generation data center. Application architectures are in transition from monolithic applications to virtualization to containerization, now to function as a service using microservices. We've gone from hardware-centric appliances to software-defined everything, software-defined networking to software-defined storage. It takes an ecosystem of partners to advance the industry and solve the challenges ahead. To move forward, the industry must address three critical vectors in parallel. First, satisfy the need for increasingly high-performance computing. AMD, via its Ryzen and Radeon, EPYC and Instinct products, is delivering advanced CPU and GPU compute technology. AMD has created many industry firsts in terms of innovative packaging, is leading the industry in chiplets, I/O technology, 3D stacking to enable AMD's latest 3D V-cache, advanced core designs, and continues to lead the industry in core count. I/O and memory subsystems must innovate to keep pace with this powerful compute infrastructure. Second, advances in storage technology are required. Advanced SSD technology, such as Micron's 176-layer NAND 7450 SSD, is a prime example. Micron's advanced QoS capabilities enable the performance and latency that is critical in scale-out data center workloads. The 7450 SSD is a great example of continuing to push the innovation curve to meet the needs of the modern data center. Lastly, enhancing the memory subsystem is extremely critical given the direct relationship between the memory and CPU core count growth. DDR5, the most advanced DRAM to date, will enable the next generation of server workloads and is ideal to keep pace with the computational needs of the next generation data center. DDR5 improves over DDR4 in many ways, from increasing the data transfer rates to improving the reliability by the use of on-die ECC and enhancing the CRC. AMD and Micron have a long history of driving innovation together. With the advent of CXL, the landscape is wide open for more strategic collaborations in the future as we optimize systems for evolving workloads. AMD looks forward to further collaboration with Micron.
Robert's history in our industry and role at a market leader such as AMD gives them a valuable perspective across so many technologies and how they impact so many industries. We really appreciate him sharing it with us all. Just as it's a pleasure for us at Micron to work closely with AMD for our product and solution testing for our mutual customers, we also collaborate when implementing AMD technologies at Micron for our own use. As an example, we were happy to recently share results of our work with AMD to use third generation EPYC CPUs with 3D V-Cache in some of our most demanding electronic design automation tasks, delivering up to 40% performance improvement for that workload. Now, you can ask any engineer, but that is an enhanced digital experience. It's easy to see how phones and computers are natural interaction points for data. Data is what these were made for. But there's much more needed to make our data experiences pervasive. From the home to the factories, smart connected devices are an increasingly critical aspect of our everyday data experiences. Devices and appliances all around us are getting smarter. They increasingly contain logic, multiple sensors, connectivity, memory and storage, generating data as we go through our daily lives. The average US household now has a total of 25 connected devices across 14 different categories. That's up from 11 devices in 2019. The main reason that these devices are getting smarter is relatively simple. The intelligence of these devices makes them easier and more productive to work with. Adding additional functionality often allows these devices to take on more tasks, remember histories, and provide greater accessibility, and improve the quality of our lives. Of course, these advanced functions often require a rather significant amount of computing power, memory, storage, and connectivity. This also means that the resources required to provide the function may exceed what can really be hosted entirely in the device itself, for many reasons. Let me share just two examples to give you a sense of the scale and highlight how the devices and compute infrastructure at the edge and in the cloud complement each other. First, let's consider one of the most widely valuable capabilities, human-machine voice interaction. It would be nice to be able to interact with machines the same way we work with humans. But as it turns out, natural language processing is really difficult for machines. The largest AI models are using hundreds of billions and approaching trillions of parameters. And they require hundreds of terabytes of memory and petabytes of storage to train on supercomputing server clusters. The type of scale needed for training language models clearly requires a scale of computing power that's only available from a cloud-like infrastructure. However, certain inferencing use cases, such as more limited speech recognition capability or command sets, can be successfully achieved efficiently by using resources on the local device itself. But broader features or more compute-intensive algorithms can then be supported by having that device integrated with compute capabilities available at the intelligent edge and the cloud. Let's look at another example of this. Our automobiles. Continued advances in advanced driver assistance, in-vehicle information and entertainment, and the broader electrification of cars are all driving dramatic semiconductor growth in the automotive segment. Current generation vehicles have orders of magnitude higher chip content versus prior generations. And that growth is accelerating to make automotive one of the fastest growing markets for many segments of the industry, memory included. As we look ahead to increasingly autonomous vehicles, all the way to level 5 and full self-driving capabilities, the capacities of memory and storage needed to implement these safety-critical, intelligent systems grows by more than 100x. I'd like you to hear from a company that is applying intelligence and software to further bring human and machine capabilities together. Rather than just focus on simply making better optical gear, Red Leader is working on some breakthrough advances via giant steps forward in high-resolution 3D vision technology based in software. Welcome to Jay Killard, CEO and co-founder of Red Leader.
Hello, I'm Jay Killard. I'm a Peter Thiel Fellow, and I've launched multiple laser satellite missions. I'm an expert in signal processing and the CEO and co-founder of Red Leader. Today, I want to tell you about the importance of the edge. It's really important to recognize where the strongest needs are. And for the most part, in autonomy, these are factories, warehouses, mines. This is the kind of dangerous work where human lives are on the line. And in these extreme conditions, application-specific hardware is really necessary for reliability. We need to take a page out of Waymo's handbook here. This means building safety-critical lasers and then pairing them with some of the most advanced AI on the planet. Now, some people like to think it's maybe only software, others prefer to focus on the hardware, but really without innovation in both of these areas from where we're at today, how else are we going to get these advanced robots to walk into our most dangerous industries? So for the companies who can manage both, this is an amazing opportunity. And one of the reasons why we're talking here today is because that all has to happen on the edge. In order to maintain safety compliant, you need to be able to actuate your system at less than 10 milliseconds. That's barely enough time to ping the cloud, let alone get run a machine learning model on it. And so all of this has to happen on the edge if you're going to generate the value we're talking about. So I want to tell you just a little bit about Red Leader and show you a demo of what it is we build. Red Leader, we're building the eyes of the machine world, and we're combining the best of 3D vision and laser communications technology. You know, some of the world's most advanced signal processing we invented right here at Red Leader to power this system you see here. So the system on the top is us versus the same hardware on the bottom with sort of traditional signal processing techniques. So as you can see from this demo and from this chat, we're already about halfway there to delivering on our small part of this grand vision for all of this autonomy at the edge. So thank you so much for your time today.
The transition of industry from analog to digital and increasingly smart and connected has been well established. Certainly, this kind of transformation requires enormous amounts of planning, rethinking of processes, development of new skills, and as a result, large-scale investment. But increasingly, businesses have discovered clear value in modernizing industrial infrastructure, integrating operating technology with information technology across industries. And we now see very broad deployments and economic impacts. In manufacturing and factory operations management, we see forecasts of incredible economic value creation through industrial IoT. As an example, operations management applications could account for between 32 and 39% of the total potential IoT economic value created in the factory setting, or up to $1.3 trillion by 2030. Now, some of the use cases leading this transformation include security and public safety video analytics, smart factories and robotics, logistics and distribution, and AR/VR in training and R&D settings. These developments and the results gained through the transformation are truly impressive. I'd like to invite an expert in the topic to share some of her deep experience and unique perspectives on how this market is evolving and modernizing each and every day. A virtual welcome to Linda Tsai, President of the IIoT business at Advantech.
Advantech's corporate vision is to enable an intelligent planet. As a global leader in the field of IoT intelligent system and embedded platform, our worldwide market share of industrial computer is 39.5%. Starting from 2010, Advantech actively develop and promote innovative IoT solutions to industrial users. We believe AI, 5G, and IoT are the key drivers for digital transformation in all aspects. IoT and digitalization is all about the data. How the data to be transmitted, how we see the data, and how we use the data, and how the data can be converted into intelligence. Partnering with Micron, Advantech provides the total solution of IoT sensing devices and intelligent edge computers, and Micron's memory and storage solution to industry users. In IoT application, those are various kinds of sensor data to be acquired, transmit, and processed. We foresee camera as the video sensor will have the largest installation base because AI and 5G connectivity. No matter in smart manufacturing, robotic AI, and transportation, industrial users not only request good quality, but also expect high reliability to be used in harsh environment. Advantech and Micron share the same vision to provide the best-in-class solution to all industrial users. Advantech is glad to partner with Micron in IQ Partner Program. With the Micron IQ feature in Advantech Industrial IoT solution, we together provide the trusted quality to all industrial applications. Thank you.
Thank you, Linda, and thank you for sharing your valuable perspectives on this crucial topic and for our close collaboration with Advantech. Bringing together ever smarter and connected devices, generating richer data, autonomously analyzed with the latest in AI technologies, can bring breakthrough in productivity, efficiency, and innovation. I am very happy to introduce Cohen Vice President of Smart Manufacturing and Artificial Intelligence at Micron. He's joined us today to share some of his experiences and the solutions Micron has applied as we've evolved our data center and manufacturing infrastructure. You'll see that the examples he shares really help pull the smart connected devices, large-scale data center processing, and digital experiences together for compelling benefits. So over to Cohen.
Thank you for the introduction, Dave, and hello to everybody. We at Micron have embraced and adopted at scale AI and other Industry 4.0 technologies as a staple way of working. As a result, 2 of our front-end factories are recognized as leaders in digital and smart manufacturing by the World Economic Forum. Today in Micron, we have over 570,000 sensors hooked up with 230 million control points. 30 terabytes of new data is captured on a daily basis, and we ingest about 34 petabytes of data in our cloud platforms to facilitate the implementation of data science and machine learning applications. Leveraging this amount of data, coupled with data science techniques like image analytics, yield analytics, and other techniques like AR, VR, help us to drive a positive impact for our operations. We see significant impact in terms of tool availability improvement, labor efficiency, and also bringing the latest generation products faster to the market. Finally, let me comment on our AR/VR program with our partners Lenovo and HoloOne. We focus our efforts on 4 main features. First of all, we enable remote expert conferencing that allows for support in troubleshooting and tool installations by our equipment partners and our internal experts without them being physically on site. Secondly, we develop augmented reality-based standard operating procedures that guide our team members through complicated maintenance activities. Our third area of focus is AR overlay of construction drawings to reduce our build errors. And finally, we leverage virtual reality for training purposes, especially with a focus on high-risk areas. I hope this gives you some insight to one of the many things we're busy with here at Micron. Thanks to you all, and back to you, Dave.
Thanks to Cohen for sharing that with us. It is important to recognize that we are not just talking about these changes, we're implementing them for ourselves. This is also a good opportunity to highlight that some of our guests today, Red Leader, Nexar, and HoloOne, are just a few of the compelling examples of startups that our own corporate venture capital team at Micron has invested in. Micron Ventures is focused on identifying innovations in areas such as deep tech and AI that are complementary to our vision and aligned to solutions of critical importance in areas such as healthcare and sustainability. We support these companies and we partner with many of them in proof of concepts and deployments of their technologies. We are excited to announce the Micron Ventures Fund 2, committing $200 million for deep tech startup investment, bringing total assets under management to $300 million. In an effort to reflect Micron's commitment to diversity, equality, and inclusion initiatives, 20% of invested capital in the new Fund 2 will be aimed at startups led by women and other underrepresented groups. Early stage equity investments are a key component to Micron's innovation strategy and not only provide key market and ecosystem insights, but also support the company's mission to drive equity, sustainability, and better health outcomes for all. As you can see, Micron believes in a vibrant ecosystem to enable pervasive, data-driven experiences. This also means we're talking about a global ecosystem and experiences. And when it comes to semiconductors and technology, Taiwan has a very special role in the industry, and it deserves a special focus as a result. I promised you special guests when we started our discussion earlier today, and now I am pleased to introduce Mr. Stephen Su, Senior Vice President of IT/ORI and the General Director of the Industry, Science and Technology International Strategy Center. Then, Micron President and CEO Sanjay Mehrotra will share his important thoughts on Taiwan, Micron, and things to come.
Thank you, Dave. I totally agree that pervasive and ecosystem mean global, which Micron and Taiwan both play as the critical roles in this pervasive roadmap. Taiwan is now shining on the world map with our leading position in the semiconductor industry. We are proud to see that Taiwan is the only region in the world to develop both the global leading logic IC technology and the most advanced DRAM technology. Micron is the largest foreign employer and investor in Taiwan. In recent years, Micron grows its talent base in Taiwan and brings the leading-edge DRAM technology here, which reinforces Taiwan's leading positioning in worldwide semiconductor industry. The efforts Micron invested in Taiwan enable Taiwan to sustain the leading advantages in terms of global semiconductor competition. E3 and Micron have established an advanced memory application platform to serve Taiwan's electronics industry verticals by providing them learning and design verification service. This platform helps DDR5 technology be easily adopted at all points in the Taiwan market. The Micron E3 cooperation also facilitates Taiwan's industrial transformation and upgrades the performance of digital data centers, 5G applications, autonomous vehicles, and industrial servers. As a Silicon Island in Asia, Taiwan is the hub of semiconductor manufacturing and can be a co-innovator and a reliable partner with the US. With a strong talent pool and a well-established ecosystem, Taiwan is able to continue the leadership positioning in worldwide semiconductor competition. We appreciate Micron's partnership very much and look forward to more cooperation in the future.
Hello. My thanks to Mr. Su for speaking on the great importance of technology development in Taiwan. Micron's high-volume DRAM manufacturing here in Taiwan is at the heart of our leadership across both DRAM and NAND technologies. Our industry-leading 1-alpha DRAM process technology delivers improved memory capacity, performance, and energy efficiency. The capabilities it delivers fuel innovation across the data center, intelligent edge, and a broadening array of data experiences. Taiwan can be proud of producing the world's most advanced semiconductor technologies, both in logic and DRAM. Our Taiwan fabs are among some of the most advanced in the industry, built to deliver future DRAM product generations while also serving as a model of sustainable manufacturing. We look forward to moving our next generation 1 beta process node into volume production here next year. And in early preparation for 1 gamma volume production, we plan to introduce EUV tools to our Taichung fab later this year. These extraordinarily complex tools use extreme ultraviolet light to form the industry's smallest features and most precise patterns. They will enable an R&D corridor that will intensify our efforts to bring up 1 gamma DRAM here and further accelerate our time to market, delivering value to our customers worldwide. These tool installations are another milestone in our continued growth and commitment to Taiwan. As Mr. Su mentioned, Micron is the largest foreign employer and foreign direct investor in Taiwan. We invest in Taiwan due to the excellent results we continue to achieve. Both front-end fabrication and back-end assembly and test coalesce here to create Micron's vertically integrated high-volume DRAM Center of Excellence. It is a leading-edge semiconductor manufacturing ecosystem optimized for scale, cost, quality, and speed. Micron has also successfully deployed smart manufacturing systems powered by AI automation that provide dramatic benefits for both operations, production yields, and high quality. We believe our achievements here are unique in the industry, and our Taiwan operations have been recognized by the World Economic Forum as a digital manufacturing lighthouse, the first in Taiwan, leading the way into the fourth industrial revolution. The core of all this success is our people. We currently employ more than 10,000 team members in Taiwan and expect to continue to grow highly skilled jobs here in the years ahead. Micron Taiwan has been recognized with multiple awards, including the top 10 best workplaces in Taiwan in 2020, Great Place to Work from 2018 to 2021, and Best Multinational Workplace in Asia in 2021. Our team's strong engagement extends to our local communities. In 2021, 80% of our Taiwan team members volunteered or donated to local charities. That dedication is crucial to our broader efforts here as well. Since 2014, the Micron Foundation has donated more than $3.7 million to communities in Taiwan with a dedicated focus on STEM programs, university education, and research partnerships. In fact, we are partnering with the Taiwan Online Learning Development Association to create science teaching materials. Nearly 80% of junior high schools have actually adopted this platform. Micron is also engaging in a Semiconductor Academy partnership with National Tsinghua University focused on cultivating electronic engineering talent for the semiconductor industry. Part of caring for our community means ensuring we operate sustainably. In alignment with the 2050 Net Zero Plan, Micron is partnering with government, academia, and our suppliers in Taiwan to lead the way forward toward achieving bold environmental goals in emission, energy, waste, and water. Micron Taiwan's strong sustainability efforts have been recognized with the National Enterprise Environmental Protection Award for 3 consecutive years. Micron's vision is to transform how the world uses information to enrich life for all. New data platforms will be truly transformative to the human experience, providing better decision-making, more equal opportunities and access, and a safer, more efficient world. Forums like Computex help align the entire technology ecosystem to work together to build systems that are capable of reaching this great future. Together, we can achieve this. The best is truly yet to come.
Thank you to Mr. Su and to Sanjay for expressing the critical importance of collaboration, innovation, and investment in Taiwan. The best is indeed yet to come. I hope you share our sense of enthusiasm for the opportunities at hand to evolve and make pervasive experiences possible from anywhere and to anyone. We need to enable all of the devices and infrastructure required to deliver these incredibly immersive and interactive experiences, and do so securely too. And we need a scalable, incredible, intelligent infrastructure that can provide the necessary data and services in a personal and contextually appropriate way, and do all of that globally. We know at Micron that these changes are going to require all of Micron's people at their most innovative. And our 40,000 plus team members globally are quite inventive. We just announced that Micron was awarded our 50,000th patent, and the number grows weekly, so we're up for the challenge. Data plays an increasingly important role in our daily lives. Ubiquitous hyperconnectivity and AI are key drivers to deliver new experiences, business value, and improve our lives in so many ways. Micron's expertise and leadership in memory and storage technology are vital assets. And our quality leadership, our complete portfolio, global R&D and manufacturing are essential to delivering to our customers and supporting their innovation. Building momentum requires working with a diverse ecosystem of customers and partners, just a few of which we've highlighted today. All of these efforts are critical to enabling an era of rich, pervasive, data-driven experiences. If I may echo the sentiments of Sanjay, when we work together, we will make this a reality and transform how the world uses information to enrich life for all. Thank you again for joining me today, and have a great week at Computex.